Why is Dynex constantly moving their SAT solver goalposts? Recently, there has been some discussion on SAT solvers around the Dynex cryptocurrency project. The Dynex project claims to have invented a new computing paradigm with powerful buzzwords like neuromorphic computing and simulated digital memristers being thrown around in their marketing like there is no tomorrow. It sounds very fascinating. Really? One of the flagship claims of the Dynex project is their Dynex neuromorphic chip SAT solver. It was claimed to be revolutionary, showing results from another world. That was, until somebody tried a real existing solvers, YAL SAT and PAL SAT, on those problems. The results were reported to the Dynex project. The publicly available results showing Dynex SAT in a negative light started a game of whack-a-mole for Sumitomo. The Dynex team was changing their messaging and technical data, constantly trying to put a positive spin on their Dynex SAT solver, while clearly contradicting their earlier statements. Let's take a look back in time. From September 2022 onwards, the claim of the Dynex SAT solver is that it is the only solver able to solve a specific problem. Even quantum computers could not possibly solve such complicated problems. We quote, existing methodologies based on current and quantum technology, reducing the complexity with Shor's algorithm to O(n)(000) cannot solve this problem today as it would require longer than the existence of the universe to find a solution. The Dynex neuromorphic chip solves the problem in 2.23s because of its inherent parallelization, its long-range order and its capability to utilize instantons. They spice that techno-babble up with this nice benchmark table showing that for any other imaginable solutions it takes longer than the universe exists. That sounds like a really long time. Be sure to note Dynex is the only working solution up until mid-May 2023 known by Sumitomo and his team. This was the given and accepted truth for over 6 months since nobody ran any other SAT solvers on the input data, outside of what references Dynex was providing. Just as recently as May 12, 2023, they even posted an article titled Dynex, Testing Efficacy and Performance of DynexSolve Proof of Useful Work that was highlighting their uniquely performant SAT solver. On Monday, May 22, 2023, benchmarks of the YAL SAT versus Dynex SAT solver were released. They showed a gain of 2 to 3x performance advantage over Dynex on average. Reporting them to the Dynex team kicked off a flurry of activity in their GitHub repository for Dynex neuromorphic chip. According to the commit history, this is all activity around the SAT solver benchmarks. As a response to the YAL SAT numbers, they add a bunch of new data points, most of which the single-threaded YAL SAT solver does not solve in their defined cap of 15 minutes. After the parallel PAL SAT numbers come in, they do more changes and add the PAL SAT results using 3 threads instead of the default 8 that they used before. With their specific configurations, Dynex SAT performs better, but is the mythical configuration there just to make DynexSolve stand out? Why do they have 8 threads as a default if the ideal number is 3? Sounds like massaging the numbers to look good. Remember that up until last week the claim was that nothing on this earth could solve the problems, except for Dynex SAT. Now suddenly you need to tune the input and solver parameters so that you can beat a solver dating back to 2017? Instead of an incredible achievement, the Dynex neuromorphic chip is now a mere prototype. We quote, in comparison, the Dynex reference implementation, which has not been optimized for speed but to showcase the calculations in a clear and understandable way in the source code, requires only between 15 to 183 integration steps to find a solution. That seems like quite a stark departure from being the only one solving it in 2 seconds and any other solution in longer than the universe exists. Additionally, before it was imperative that what matters is the speed that it takes to reach the solution. With the new benchmarks, the metric of time to solution is irrelevant. Instead, they reference the mathematical elegance and efficiency of their algorithm by counting integration steps. We probably can't appreciate the elegance of it, but for efficiency, I think anyone with some memory of basic high school physics can question that. In the SAT videos linked in the description, you can see Dynex going full throttle for over 2 minutes on 9 CPU threads. PAL SAT uses a maximum of 8 that fluctuate from 0 to full load for just under a minute in total. Let's round those 2 minutes for Dynex and 1 for the PAL SAT solver. We assume CPU is fully loaded for the run of the benchmark suite. The workloads are not identical, but the margin in length of the computing time is large enough that we can assume they would fully saturate an 8-core Ryzen like the 5800X. If you run that on for 1 minute or 2 minutes, you can reason that it will use around twice as much energy for the same result with the slower solver. Is that more efficient? How? As always, we invite Sumitomo from Dynex to respond to these simple questions on a public forum. Because you tried unsuccessfully to delete the Dynex Bitcoin Talk thread, we invite you to write a comment on this video.